If we look at this square PQRS, I'm going to put the point T anywhere inside this square. I'm not fussy where it goes. And I'm going to join up the triangles TQR and PTS. So the next thing I'm going to do is I'm going to draw a line parallel to PQ through the point T and a line parallel to QR also through the point T. So now I've divided my square into 8 regions. If I call this line X, Y, and this line AB, I'm now going to concentrate on this rectangle PATX. If we look at this rectangle, we have a diagonal PT, and so I see that this part, PTX, is a half of the rectangle. And I can go round the square looking for half of a rectangle each time. So here, the triangle XTS is half of the rectangle XTBS. And I can do the same at the bottom, and in each case, the bit that I'm shading in is half of a rectangle. So we see that altogether, I have a half of this rectangle at the top and a half of the rectangle at the bottom, and altogether that makes a half of the whole square. So no matter where the point T is, these two triangles always have an area which is half the area of the square. Now this is not the only way I could do this question. I could consider the triangles and use my formula, a half the base times the height, because I notice that if I call this height 1 and this height 2, then the area of the triangle QRT is a half of QR times H2, and similarly the triangle PTS is a half of PS times H1. But QR and PS are equal, and H1 plus H2 is the side of the square, and so I see that the sum of my two triangles is a half of this length times this length, which is a half the area of the square. Now we're told that the area of the square is 100 square centimetres, and we've now proved that our two triangles add up to half the square, which is 50 square centimetres. We were told that TQR was 24 square centimetres, and so PTS is 26 square centimetres, because 24 plus 26 equals 50. And so my answer is 26 square centimetres.